Hello friends, welcome to the BPSC junction. Let's start with the chapter number 5, that is water. When you think of water, what images come to your mind? You think of rivers, the waterfalls, the pitter or patter of raindrops, water in your taps. Children love to float paper boats in rain puddles. By noon, the puddles vanish. Where does the water go? The sun heat causes evaporation of water vapor. When the water vapor cools down, it condenses and forms cloud. From there, it may fall on the land or sea in the form of rain, snow, and or sleet. The process by which water continuously changes its form and circulates between ocean, atmosphere, and land is known as water cycle. Terrarium. It is an artificial enclosure for keeping small house plants. Our Earth is like a terrarium. The same water that existed a century ago still exists today. The water used to irrigate a field in Haryana may have flowed down the Amazon River 100 years ago. The major sources of fresh water are the river, ponds, springs, and glaciers. The ocean bodies and the sea contains salty water. The water of the oceans is salty or saline as it contains large amount of dissolved salts. Most of the salt is sodium chloride or common table salt that you eat. Distribution of water bodies. We all know that the three-fourths of the Earth's surface is covered by water. If there is more than land on this Earth, why do some countries face water scarcity? Is all the water on the Earth available to us? The following table gives the distribution of water in percentage. Ocean 97.3 percentage, that is saline water. Ice cap 2%, groundwater 0.68%, freshwater lake 0.009%, inland seas and salt lake 0.009%, atmosphere 0.0019%, river 0.0001%, that is all equal to 100%. Salinity is the amount of salt in the gram present in 1000 grams of water. The average salinity of ocean is 35 parts per thousand. Do you know Dead Sea is in Israel has salinity of 340 grams per liter of water? Swimmers can float in it because the increased salt content make it dense. Water distribution can be demonstrated by simple activity. See the box. Water is absolutely essential for survival. Water alone can quench your thirst when we are thirsty. Now, don't you think that you are wasting a precious resource when we use water carelessly? Ocean circulation. There is something magical about walking bare feet on the seashore. The wet sand on the beach, the cool breeze, the sea birds, the smell of salt in the air, and the music of waves. Everything is so fascinating. Unlike the calm water of ponds and lakes, and ocean water keeps moving continuously. It is never still. The movement that occurs in ocean can be broadly categorized as waves, tides, and currents. March 22 is celebrated as World Water Day when the need to conserve water is reinforced in different days. Waves. When you are playing throw ball on the beach and the ball falls into the water, what happens? It is a fun to watch how the ball gets washed back to the shore by the waves. When the water on the surface of ocean rises and fall alternatively, they are called waves. Waves are formed when wind scrape across the ocean surface. The stronger the wind blows, the bigger the waves become. During a storm, the wind blowing at very high speed from huge waves. This may cause tremendous destruction. An earthquake, a volcanic eruption, or underwater landslides can shift large amount of ocean water. As a result, a huge tidal wave called tsunami that may be as high as 15 meters is formed. Largest tsunami ever measured was 150 meters high. These waves travel at a speed more than 700 kilometers per hour. The tsunami of 2004 caused the widespread damage in coastal areas of India. The Indira Point in Andaman and Nicobar Island got submerged after tsunami. Tsunami is a Japanese word that means harbor waves, as harbor gets destroyed whenever there is a tsunami. Tsunami. The earth Panodonium. Tsunami is the harbor wave struck havoc in Indian Ocean on 26 December 2004. The wave was the result of earthquake that has its epicenter close to western boundary of Sumatra. The magnitude of the earthquake was 9 on the Richter scale. As the Indian plate went under the Burma plate, there was a sudden movement of sea floor causing the earthquake. The ocean floor was displaced by about 10 to 20 meters and tilted in downwardly direction. A huge mass of ocean water flows to fill in the gap and that being created by displacement. This marked the withdrawal of water mass from the coastline of land masses in South and Southeast Asia. After thrusting of Indian plate below the Burma plate, the water mass rushed back towards the coastline. Tsunami travel at the speed of 800 km per hour, comparable to the speed of commercial aircraft, completely washed away some of the islands in the Indian Ocean. The Indra Point in the Andaman and Nicobar Island that marked the southernmost point of India got completely submerged as the wave moved from earthquake epicenter from Sumatra towards the Andaman Island and Sri Lanka. Wavelength decreased with increasing the depth of water. The travel speed also declined from 700 to 900 km per hour to less than 70 km per hour. Tsunami waves travel up to the depth of 3 km from the coast, killing more than 10,000 people and affected more than lakhs of houses. In India, the worst affected areas were coastal area of Andhra Pradesh, Tamil Nadu, Kerala, Pondicherry, and Andaman and Nicobar Island. While the earthquake cannot be predicted in advance, it is possible to give a 3-hour notice of potential tsunami. Such early warning systems are in place across the Pacific Ocean but not in Indian Ocean. Tsunamis are rare in Indian Oceans as the seismic activity is less compared to Pacific. The tsunami that raves the South and Southeast Asian coast in the December 2004, the most devastating tsunami is the last several hundred years. The large damage caused in the life and property was primarily as a result of lack of monitoring, the early warning system, and knowledge among the coast dwellers of Indian Ocean. The first indication that tsunami is approaching is the rapid withdrawal of water from the coastal region, followed by destructive wave. When this happen on the coast, instead of people going to high ground, they start assembling to the coast to view the miracle. As a consequence, there was a large casualty of curious onlookers when the gigantic wave struck. Tides. The rhythmic rise and fall of ocean water twice in a day is called tide. It is a tide when the water covers much of the shore by rising to its highest level. It is low tide when water falls to the lowest level and recedes from the shore. The strongest gravitational pull exerted by sun and the moon on the earth's surface causes tides. The water of the earth closer to the moon gets pulled under the influence of moon's gravitational force and causes high tide. During the full moon and the new moon days, the sun and the moon, the earth are the same line and the tide are highest. These tides are called spring tides. But when the moon is in its first and last quarter, the ocean water gets drawn in diagonally opposite direction by the gravitational pull of sun and earth, resulting in low tide. These are called neap tides. High tides help in navigation. They raise the water level close to the source. This helps to ships to arrive at harbor more easily. High tide also helps in fishing. Many more fish come closer to the shore during the high tide. This enables fishermen to get plentiful catch. The rise and fall of water due to tides are being used to generate electricity in the same place. Ocean currents. Ocean currents are the streams of water flowing constantly on the ocean surface in different direction. The ocean current may be warm and or cold. Generally, the warm ocean current originate near the equator and move towards the pole. The cold current carry water from polar on higher latitudes to tropical or lower latitudes. The Labrador Ocean current is cold current while the Gulf Stream is warm current. The ocean current influences the temperature condition of area. The warm current brings about the warm temperature over land surface. The area where the warm and cold currents meet provide the best fishing ground of the world. Areas around Japan and eastern coast of North America are such examples. The area where warm and cold current meet also experience foggy weather making it difficult for navigation.